Well, welcome back to the second session. It promises to be exciting. So in this session, we're going to talk about determinant, okay? Determinants and then inverse of a 2x2 matrix. How do we do that? So the determinant is actually used to compute the inverse of a matrix, a matrix. So determinant is given. I think I need to show you that. So from your screen, assuming you had a matrix A given by the elements C and D from here, okay, what we're saying is that now to find the determinant of the matrix, first of all, the end goal is to work out or calculate. The end goal is to calculate the inverse of matrix A. But before you can do that, you have to first obtain your determinant. Okay, so how do you work out the determinant? Determinant of A is given by multiplying these two together, A times D, yeah, and then subtracting B times C from it. So you have A times D into bracket minus B times C. Now, if you noticed what we've got in here, just as we've got in here. Now, if you notice, there's this symbol. Let me not mention. Let's carry on. Where are you now? Where is that? Great, there we go. Okay, so finding the difference between these two will give you the determinant of your matrix. Again, the next thing is for you to know is that if the determinant is equal to 0, then A is called a non-singular matrix. An example of a non-singular matrix is this. So say you have 3, 9, 1, 3, something like this, a matrix of this nature. And to work out the determinant of this matrix, so let's say this is matrix B, working out the determinant of this matrix will give us 3 times 3 minus 9 times 1. Now 3 times 3 is 9, and 9 times 1 is 9. So this will give us 0. So all this means is that this matrix B, because the determinant of matrix B is 0, matrix B cannot be inverted, or you cannot find the inverse of matrix B. Okay, so any matrix with a determinant that's equal to 0 is an invertible matrix, which means that it's also called a singular matrix. Okay, let's carry on. Next slide. Right, so you need to identify if this matrix is invertible or not. So what do? You multiply 2 times minus 2 times 1, and then have 3 times, subtract 3 times 8 from that, and that gives us the answer that you see in here. So our answer on our screen is minus 26. So after we've identified that minus 26 is not equal to 0, this is a non-singular matrix. So it means that it can be inverted. Right, so after calculating the determinant of that matrix A, we carry on to find the inverse. So we found the determinant of A to be minus 26. Now, how do we find the inverse? Inverse of A can be written as this, okay? Inverse of A. So the inverse of A equals 1 over the determinant of A by the opposite of the A values. Okay, the opposite of the A values. Now, how do we find that? Initially, our A was on your slide, as you can see, is minus 2, 8, 3, 1. On your slide. From your slide, you could see that the inverse, the value is minus 2, 8, 3, 1. Okay, so I hope I didn't miss anyone here. Right, so what you're saying is that we're trying to find the inverse values of A. How do we do that? So A, in this context, you need to switch the values. So what we do is that we switch places of element A, which is 2, and element, this is D, element D, which is 1. We switch their places. So that will be written now as 1, negative 2, okay? And for element B and C, what we do is that we negate them, okay? We negate them. So we put a negative value there. So that's going to be negative 8, negative 3. So in all these, two things happened. First, you swap places of elements A and D, and then you negate elements B and C, okay? So this is what we're going to put in there now, yeah? So this is the new value, which is 1 minus 8 minus 3 minus 2. 1 minus 8 minus 3 minus 2. So now I could erase this bit, take this bit off. Now, since we know what the value of our determinant of A is, we can confidently put that in here. And so we'll replace that minus 26 there with determinant of A in this. So that's going to give us minus 26. So my final A inverse is given by, my final answers will be minus 1 over 26, because I'm multiplying this by that. And then this is going to give me minus 8 over minus 26. Now this will give me minus 3 over minus 26. And now the last one is minus 2 over minus 26. Okay, so now here you can reduce it. You can reduce these values. Possibly, the only one that can do some good division here is 2. So 2 is likely to go into itself 1 and go into this one, 13. However, because we've got negatives here, negative will cancel negative, negative will cancel negative, negative will cancel negative. So my final answer will be minus 1 over 26. That's the first one. 8, 3, 8, 24. Okay, so that's not going to work. So we have 8 over 20. Here as well, 8 divided by 26. We could have reduced that to something lower. So 2 could go into here 4, and 2 could go in here 13. So that would be 4 over 13. Okay, and then the last bit we have 3 over 26, which is positive, and this is 1 over 13. So this is going to be our final answer. This is going to be our final answer for the calculations we've made. Okay, great stuff. Right, so what is next here? So this is another example. I'm just going to talk you through it. You have two 0.5, 1, 0, and then you find, first of all, find the determinant. The determinant is multiplying 2 times 0 minus 0.5 times 1, and that is giving us 1 over minus 0.5. And 1 over minus 0.5, instead of speaking it, I think I should calculate it. So we've got, what other values? Why don't I get the video up for you to see? So we've got A equals 2, 0.5, 1, and 0. Is that right? Great. Okay, so the determinant of A is, first of all, 2 times 0 minus 0.5 times 1. So this is 0. This is giving us 0. So 0 minus 0.5 is minus 0.5. So that's the determinant. So then we find our inverse is 1 over the determinant, which is minus 0.5. And then we reverse and do the changes we have to do to this. So these two will change. 2 and 0 will change. They'll swap places. So that's going to be 0, 2. And 0.5 will have a negative there. 1 would also have a negative. That's all we do there. So then we multiply this coefficient across, or this scale factor across. However, do not forget that 1 divided by 0.5, this is half, like 0.5. 0.5 can go into 1 2 times. So that's going to give me minus 2. Okay, you can use your calculator to do this. So it's going to give us negative 2. So negative 2, and I'm having 0 minus 0.5 there, minus 1 and 2 here. So I multiplied this across. Minus 2 times 0 is 0. My final answer. Minus 2 times 0 is 0. Minus 2 times minus 0.5 is 1. Minus 2 times minus 1 is giving me 2. And minus 2 times 2 is giving me minus 4. So this should be my answer, my final answer. I think we should check with the screens to see if we've got the same things. I'll give you 3 seconds to just look at what we've done, and then we could double check with what is here. So let's move down. We go. Oh, great stuff! Great stuff! Great stuff. Okay, that's it. Now we move on to the final bit, which is solving equations with matrices. Solving equations with matrices. So suppose A is not a singular 2 by 2 matrix, such that AX equals B, where B and X are both 2 times 2 by 1 matrices. We can then write an expression into trying to find X from this. Okay, so I'm going to rub this off and we carry on with that one. Yeah, we're nearly there. So we're saying that AX equals B. How do I make X the subject? Now I need my video to come up. How do I make X the subject? Okay, so what I do is that if I multiply through by the inverse of A, inverse by A and X, which is multiplying this through having the inverse of A here, inverse of A times B. Okay, let me put a dot there, a dot for you to know that there's something happening. So now this, a matrix and its inverse, when you multiply that together, will give you what we call the identity matrix. Okay, we'll give you I there. So it's like saying half times 2 will give me 1. Okay, and 1 is essentially the identity matrix. So the inverse and the matrix will give you an identity matrix. This is 1. Okay, so 1 times x is inverse of A times B. So this is x equals inverse of A times B, which is my final answer. Okay, so this is a way mathematically we'll call this matrix maths. Okay, matrix maths. Mathematically, this is the way to solve a equations using matrices. Okay, now we'll do that with what we see here. We'll do that with what we see here. So in light of trying to solve simultaneous linear equations using matrices, what you're looking out for is trying to pick out the coefficient of the x, y, and the constants. Okay, you're trying to pick out the coefficients of the x, y, and the constants. What do I mean by that? Someone is asking, what does he mean by that? Let's get to that. And so in that context, what do I mean by that? Let's do this. Bring my screen up. So we're saying you have ax plus by equals p. And then the next one is cx plus dy equals q. Now, this is a simultaneous equation, but this simultaneous equation, you could work it out simultaneously. But now, in the context of matrix, you could convert the simultaneous equation into a matrix and solve them. Okay, so that's what we're trying to show you here. Okay, now, in trying to take out the matrix or split it apart into a matrix, we're saying these are x coefficients of x and these are coefficients of y. These are constants. So what do? This looks like a 2 by 2 matrix. Okay, so I'm saying that A, pulling that out to be A, B, C, D is looking like a 2 by 2 matrix. Yeah, and then that will give me x and y. Okay, which is also going to give me, so this, right, let's carry on. And then that's going to leave me with PQ as a final component. Okay, so now looking at this, we could classify this as if you remember, we had this expression. If you had an expression ax equals b, how would you find your x term? How would you find your unknown? So we could use this in that same fashion, where we are saying that these are numbers, these are letters, these are also numbers. How do we find what these variables are? Okay, we are trying to find the x and y variables. How do we find them? So we're using the same concept from how we made x the subject here. So we're saying that x, y here, which is just like x. If you remember, we had our final solution to be x equals inverse of a dot b. Okay, so we're saying that, so whatever this is, why don't we call this matrix, I'll give it a name, maybe, what do I call this? Let me call this matrix W, and I'll call this one to matrix Z. Okay, so what we are saying is that if I had this matrix, so W with an unknown, which is x equals z, and I wanted to find x, which is your xy component here. Okay, why don't I make this, I'll make this x bar. So I'm trying to find x bar here, this whole thing, this whole matrix. Okay, I'm making it x bar. So I'm trying to find x bar. It's the same thing as x bar equals inverse of w dot z. See, inverse of w dot z. So which means that everything here, I'm going to find the inverse of w here dot z. And that will give me the answer of xy. Okay, inverse of this dot z. Okay, and we know that to find the inverse, we need to calculate the determinant first, and then do your switching, your exchanging things, and that will give us the answer. Why don't I go to the slide? Yeah, so here, from here, you're having xy equals, now all this component here now, yeah, is representing your w inverse, whereas this pq is your z. So here they found the determinant here, and here they did the swapping and then the minus thing here, and they multiplied whatever we have here, now so w inverse multiplied by the final how do you call it, column matrix here, okay, or column vector. So using that same principle, I think we've got, do we have a few questions here? What slide are we on? We are nearly done with the whole topic. We're nearly there. Let's see. We've gone through 15 minutes. Using that same concept, we've got a question on the slide which is saying 2x plus y equals 9, and this is x minus 2y equals minus 8. So we're going to solve this simultaneous equation using matrices. Bring back my video, give you a close-up look. So why don't I break this down? So we're looking at the coefficients in front of this. In front of this x is 1, in front of this y is 1. Yeah? So we're saying that in a nutshell, I'm going to break this down, and that will give me a matrix 2 in front of this x, 1 in front of this y, 1 in front of this x, and then here, look at this, minus 2. Do not ignore the you don't say charge here. The arithmetic symbols. If it's a plus, you don't write anything, but if it's a minus, you make sure you indicate it. Okay, so that's leaving me with xy here, which is equal to 9 minus 8. Great, 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 great stuff. So here, now I'm saying that my xy should be equal to 1 over my determinant, and my determinant is me multiplying 2 times 2, 2 times minus 2, which is 2 times minus 2, minus 1 times 1, which is 1. And then I'm going to reverse this, okay, put it in the inverse form. So these two are going to swap places. So I'm having minus 2, 2, and then these two guys here will have minus negative 1, negative 1. Okay, so we are going there. Now, then dot, my final form, which is 9 minus 8. Okay, so this whole thing is the inverse of this guy here. This whole part, this whole section is the inverse of this element here. Okay, so we're saying that 1 over, this is minus 4. Minus 4 minus 1 is giving me minus 5. Multiplied by minus 2, minus 1, and 2, dot 9 minus 8. I don't have space anymore to do this. Great, 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 great. So, in trying to finish this up, what do I do? Okay. From here, we are taking these values up. So at the moment, we've got our x, y to be equal to minus 1 over 5, minus 2, minus 1, minus 1, 2, dot 9 minus 8. So I can clean that. I've written this back to the top so that you can follow. So from here, oh dear, keep this here. From here, we're saying my answer is minus 2 times that is a negative times this. This is a positive now. So that's 2 over 5. Now, minus 1 times this, that's a negative, so that's a positive. So that's 1 over 5. This is also giving me a positive, so that's 1 over 5. And this times this is minus 2 over 5. Okay? Dot 9 minus 8. So here,